Good morning, everyone. My name is Jaeden. Today, me and my group are going to show our project titled Application Development using Cancel Learning to differentiate AI-generated and human images. So, why did we pick this topic specifically? So, first of all, as the technology of AI image generators are advancing, it's going to be more widespread and harder to differentiate AI-generated images and human-made ones. This advance in technology raises questions on ethics of AI generators and the validity of real human-made art, as it's way harder for us to learn how to make art than the prompt engineers to generate their own AI-generated
My
artwork.
name is Nicholas Gabriel and right now I'll explain to you about our research question. From our background, we formulated a research question, which is, what is the best way to create an effective method to detect AI-generated artwork or images? So now I will explain the control flow of our deep learning model. First, we obtain our pre-trained model. In our case, is residual network 34, which is a convolutional neural network developed by Microsoft Research Asia. Then we will load the pre-trained weights, and then we will get the raw data set, which is the AI Art Bench dataset from Kaggle. We will label each dataset by organizing it into separate folders, and we will split the dataset into a testing and a training dataset. We will also use the testing dataset for validation. There will be 20,000 testing images and 100,000 training images. So we will then train the model using the training dataset, and we will evaluate the model using the testing dataset. If the model's accuracy is too low, then we will alter the parameters and retrain the model again. Once we find the right parameters and the accuracy is high enough, we will develop the application and publish an application that contains our Siamese neural network.
So, this is the flowchart of our application, which starts from the user opening our application. Then they will click Start Now, which initializes the application, and the user starts to upload the images. And they get sent to a screen where they are allowed to upload images directly from their files. After that, the model will start analyzing the image and will predict. And then it will classify it into two, either AI-generated or human-made. And then the outcome will be printed. After that, a model will check if there are any other images by the user uploaded in the first batch. If there are still more images, the model will go reroute itself and start to analyze the other images. If there aren't, the user will upload more images, or if they don't, it will finish. But if they do, it will get rerouted back to the file uploading screen. So these are the results of our AI. When we first trained the model, it presented us with the loss versus epoch graph. So the blue line, or the training loss, decreases because the errors in analyzing the pictures decrease as it gets more and more trained, which means it's getting better at analyzing the images. Thus, the validation loss is supposed to also go down. However, in our case, it varies and bumps up and down. And this may be caused by the lack of images while training, as other people will train it with way more images than us.
This is our confusion matrix. A confusion matrix shows us positives and false positives in the results, as well as negatives and false negatives. Using this information, we can calculate the precision and the accuracy using those respective formulas. We have found that the precision is 87.7% and the accuracy is 85.975%.
From the results of our confusion matrix and calculation from our formula, we can analyze the results of our precision and accuracy. The precision we calculated was 87.7%, which means that the chances for false positives are relatively low, and our AI was correct at predicting positive around 87.7% of the time. Next, our accuracy was 85.975%, which means that it's fairly accurate at detecting AI images or real images, but it also shows that there is room for improvement.
From the data that we collected and our analysis, we can now conclude that creating a model using a Siamese neural network and the transfer learning technique is highly effective, with the results having fairly high accuracy and a great precision. This means that our deep learning model can differentiate between AI-generated images and human-created images effectively.
After it all, we have a couple of suggestions for future researchers who will want to use our report as a base. So firstly, they should increase the number of images used for training the AI model to increase the accuracy and precision. Next, they could double check the dataset for inaccuracies such as wrongly labeled images, variability in the images, such as image resolution and other things hidden in the metadata of the images. Thank you.